goes to your electricity cabin, and from that electrical cabin, in every building or in every locality, probably you will happen to see earthing pit made. So how is this earthing pit made? This is very important, because suppose tomorrow if you will start working as a biomedical engineer in some newly coming up hospital, and definitely this question will come in front of you, that where should we make earthing and how we should make earthing, because in the hospital there are various types of equipment, and some of the equipments are really power consumers. You know, they need a lot of electricity, and equally they need a proper earthing. So these are the certain steps which are given here, how the earthing pit is constructed. For having a proper earthing, this is the recommended way, that one needs to make a earthing pit of given dimensions, and you need to put a galvanized iron plate inside, which is measuring approximately 60 centimeters by 60 centimeters and 10 centimeters thick. And one needs to have a mixture of wood, coal and sand and salt covering this entire pit. So this sand offers the porosity. So if you are putting water inside, this water will get mixed with, will percolate through the percolate through the sand, and it will mix with salt, and it will provide a conductive path for the leakage currents directly to the ground. And then from this GI plate, you are supposed to take a galvanized iron strip outside, and then all your earthing connections which are coming out of your building are then connected to this GI strip. Now, in most probably in your house or in the equipments which you normally handle, you must have, most of these equipments are working on 5 ampere connections, or at the most at your house you might have seen equipments which are working on 15 ampere plug top. Maximum, that is the wire connections you have seen. But when it comes to biomedical engineering equipment, you will find equipments which sometimes need 100 kVA supply, or much more than that. For example, equipments like your MRI, or equipments like your CT scanners or cath lab, you know, their generators actually consume a lot of power. So you can't use simple wires which are used at your residence, yeah, because they are actually designed for very low current capacity. So for high power connections, you require special types of cables, and these cables are available in terms either in 3-core type. 3-core type cables are typically what we are using it for domestic purpose, or at the most for the currents which are going up to 15 amperes. But if you are connecting a very heavy load, then probably you will require a 4-core cable and you will require a 5-core cable. 4-core cable and 5-core cables are used typically where you need 3-phase power supply for running an equipment. And especially in 4-core cables, you will find that there is an armor shield around those 4 cores. So what happens that if you are laying this 4-core cable through ground, still there could be less of damage, you know. Like suppose you have already laid this cable below the ground and somebody is digging floor for something else, this shield will give some kind of protection. This shield also can be grounded, or this shield will also help you to protect it from rodents and all. In 5-core cables, there are usually 5 cables are used for either for 3 phases, 1 neutral and 1 earth. Now in India and in Europe, there are 2 different electrical standards you will observe. Like in India, suppose there is a power supply coming to a control panel, you will find that the 3 phases, there will be a typical color code used for these 3 core of phases. Like either the phase will be either RYB, that is, it will be red, or it will be yellow, or it will be blue. In Indian standards, the neutral is always black and the earthing is green. You know, but if you will see a European equipment, especially equipment coming from Germany or from Europe, there the color coding is different. If it is a single phase, then always the phase will be a brown color phase. And if it is a three-phase supply, then the phases will be either black and grey, you know. And in Germany, they always use blue color for neutral, and again green is for earth. So, but what can go wrong? Suppose there is a electrical panel designed by an Indian company which is installed on the wall, and if you are trying to connect your imported equipment, say imported equipment which is imported from Germany or some other country, there actually the neutral color is different and the phase color is different. So if by mistake if you will connect blue of that machine to your phase and black to neutral, there could be disaster. Yeah. So one needs to understand that there are two different color codes which are observed in India and in other countries. So one needs to ensure before making a wire connection what wire is what and which standard is followed. Now, what are lugs for? I don't know if anybody has seen a very high current carrying capacity electrical cable. In our domestic house, if we are connecting a wire to a plug top, what normally we do, we strip the insulation of the wire, and then we put those strands inside the plug top, and then we tighten it with the help of screw. But in case of high current carrying capacity cables, electrical cables, you can't have this kind of connection. Means you can't put those, you can't just remove the insulation of wire and directly put it into the terminal strip and you can't tighten it. You need to have a special types of terminals for every cable. These special terminals are called as lugs, you know. And these lugs are not soldered or anything to the cable. You need to choose a proper size of lug. You need to put your cable inside that, and then there is a special tool which is called as the crimping tool. Using this crimping tool, you have to press this lug against these wire connections, you know, just to ensure that there is a firm connection in between, and then these lugs are directly tightened into the terminal string. If wrong lug is used, then probably it will increase the joint resistance, yeah, and it can limit the current, or whenever you need high power through this cable, the cable will not be able to supply it. Now another aspect which most probably is not covered into syllabus, or which we never talk in our day-to-day life, that is called as the mains impedance. One needs to understand that what electricity comes on the wall socket is not directly produced in the next room. It comes from a very far distance, and this electricity comes through a very big distribution network. This distribution network contains a lot of cables, transformers, joints, connections, panels, many things. And every component which is coming in between has a limiting current effect, you know. So especially if this mains impedance comes into picture, and one needs to measure this mains impedance when you are especially connecting an equipment which is consuming very high electrical power, yeah. Because as you can see the picture over here, if there is suppose the wire connection is not made properly, then or the wire connection is done without using a proper lug, then when you are drawing a high current through this wire, suddenly there will be a more voltage drop across this resistance, across this joint resistance, and which will limit, or which will affect the power delivery to the equipment. So this means there are special meters available for measuring the mains impedance, and usually this mains impedance you need to check for every equipment in the manual how much mains impedance has been prescribed, and before connecting the equipment to your panel you need to make this measurement. Now how to measure? Number of times in three-phase electrical systems, or the systems which are working on three-phase power supply, you need to you need to measure, there is a voltage specified for operation of every equipment. Now, how do you measure it? You can either measure it with the help of your multimeter also between the voltage between two phases. Yeah, but at one place, suppose the voltage is coming less, then you also need to know the relationship between the single phase voltage and and then what potential difference it will provide between two phases. So the formula is the potential difference between two phases is √3 multiplied by a single phase voltage. Yeah. So if you have a 220 volt supply coming into the into single phase, then if you are multiplying it by √3, then phase to phase voltage will become approximately 380 volts. There is an important word in electrical engineering, what we call as civil. You know, this is the key to remember a phenomena. In the pure resistive circuits, typically whatever current you are delivering to that system, it will you can directly calculate with the help of formula like V is equal to IR. You know, but the equipments which include inductors and capacitors, there actually this calculation is not so easy. Yeah, because inductors and capacitors, they respond in a different manner to AC electrical power. Like if you are trying to inject current into a load which is containing only inductors, it will try to obstruct this AC load. And if you are supplying DC to an inductor, it will act as a short circuit. But if you are similarly, if you are trying to inject current into a load which is containing capacitors, then capacitor acts as a short circuit for AC and it blocks DC. It gets charged. You know, so as a result, in circuits which are containing inductors and capacitors, the current and the voltage are never in phase. Either the current is lagging the voltage, or it is leading the voltage. So the key to remember is this civil. C stands for capacitance, I stands for current, V stands for voltage, again I for current and L for inductance. So in a way you can say that by word civil, in capacitor I, that is current, is ahead of voltage V, and in inductor the L, the alphabet which is coming at the end, current is lagging voltage. So what is power factor? What actually power you are delivering to the system is not entirely used. Some of the power remains stored into these components and then it is paid later. Hello? Yeah, it is okay? Yeah. So there is always a phenomena which is called as the power factor, and one before actually designing the or before choosing appropriate cable for electrical connection, one also needs to take consider this power factor which is coming into picture. Hello. Yeah. So if someone asks you that I have an equipment which consumes 3 kilowatt of power, then what kind of cable I should use for this type of equipment? Then there actually first of all you need to consider the power factor. What is if you don't know the power factor, how much actually power this equipment will require, then you need to consider the power factor, divide the kilowatt load, divide this kilowatt load by the power factor. Then you come to a figure which is kVA. So in this example, suppose the equipment is consuming supposed to consume 3 kilowatt, you divide that by power factor of 0.8, so you get a figure of 3.75. And if you are dividing this 3.75 by 230 volts, it tells you what current you will require. it will be 16.30 amperes. Can you calculate a current flowing through each phase? Yeah. So the very simple technique is you can divide this three-phase load into per phase. So for example, if the equipment is designed to consume 36 kilowatts, then if all the phases are balanced properly, there will be a load of say 12 kilowatts on every phase. Now you divide it by power factor. If you don't know the power factor, use the figure of 0.8. So 36 kilowatt for a three phase means 12 kilowatts per phase, and when you are dividing this 12 kilowatts with the help of power factor, you are reaching a figure of 15 kVA. And once you divide this 15 kVA with phase voltage of 230 volts, then you are arriving to the figure of 65 amperes. What is voltage drop in cables? Yeah, everyone will agree that every conductor, yeah, whether there is a resistance, has some kind of resistance, and this resistance of every conductor depends on the which is directly proportional to the length of this conductor, and it is inversely proportional to the cross section of this conductor. There is always one more factor which is called as rho, which indicates the coefficient of resistivity, and this coefficient of resistivity changes from material to material. For example, aluminium has a higher coefficient of resistivity compared to copper. So if you are using aluminium cable, then probably you will have to use a thicker cable compared to copper. Yeah, and